monotonous.
Don't know what it is about you, Zachary.
Let's roll. Alright, what do we got here? Looks like I... Alright, let's go. Whoops.
The hunt is on. Let me have it.
Alright, let's call it. Hello. I wanted to show you this idea I had the other day. It's called Hercules. The idea is combining semi-randomized workouts, for example with the rings or push-ups on the ground, while you're playing a run through the game of Hades. And I figured you could use the random aspects of the gameplay to selectively choose different workouts to do. They're all body weight. You can actually do it in your apartment while you're playing the game. Here is the website. If you scroll down, you can see all of the exercises currently available. The whole idea is extremely simple. Anytime you have a boon selection in the game, you just hit roll here, and it gives you 3 choices of exercise to work through. For different boon rarity, you have common, rare, epic, and heroic, and the number of reps you're required to do to select that boon choice in the game corresponds to the rarity. It's very simple, but I do promise that it actually works already. You can actually go to this website. The link will be in the description of this video. Give it a try if you'd like. I'm really pleased with how it turned out. In particular, I'm happy that 1, the idea worked in general. 2, it was more fun and more difficult than I thought it would be in terms of the exercise. And 3, making the assets for this web page was a lot of fun. In a minute, I'm going to go through sections of the code. I think is a good example of how you can have a lot of fun with code and creativity mixed together. Without further ado, I'm going to go and pop open the code and give you a look at that. Okay, let's have a look at some code. I'd like to start by popping open the deps file. The dependencies I save into a file called deps.eden. This is a way where you can use official closure tools to indicate the libraries that your code is dependent on. When you run CLJ in your terminal, it'll download the artifacts from wherever you specify. Usually you get it from a Maven repository with a specific version number. Closure script is basically a dialect of Closure that transpiles into JavaScript. Reagent is a wrapper library for React. It's a really nice library. Same-ish is a small library that checks floating point values. Figwheel-main is a really cool library that lets you do what's called hot reloading. Hot code reloading looks at your files and will automatically update the web page without you having to manually refresh things most of the time whenever you make code changes. Makes for a really nice feedback loop. When you use that alongside the REPL for some REPL driven development, it's a fun way to do iterative buildup of apps. I have a svg-clj library that I'm working on. It's open source. You can actually go to it now and try it out yourself. It's a set of tools to help you programmatically create SVG diagrams. Think of it kind of like creating CAD drawings with simple programming. Instead of a Maven repository, you can actually use a Git repository, provide the URL, unique commit SHA. It will pull that code and compile it into your project like any other source, and it works just fine. You could actually visit the GitHub for this source code, clone it, and be able to successfully run this project on your own computer. The next thing I have all ready to go is a few resources. In particular, this is a very minimal style sheet that I use for most of the projects. I like to keep CSS as simple as possible. This is the HTML that all the code gets put into. You want to have a div with an ID tag that you can target with Reagent so that it crams all your app in there. I'm actually ready to go right into building this project, and I'm going to go ahead and start with a namespace because you need it. So I'll put it in there. Pull this up here, and now I've got my REPL ready to go. I evaluated that, and now I'm in Hercules.main, and we are ready for business. Let's split this and start making a bit of the document. I'm going to show you hot code reloading by changing what shows up here. So what is the doc element? Let's define that here. It's a function, and it's going to return hiccup data structures that actually get rendered in properly as React components. Hercules, I'm going to call it that. Use the game Hades to get strong in real life. This tag, you can kind of treat it as a empty container. If I save this, it'll hot reload. Once I make sure I define the mount function, of course. This is, by the way, what happens with Figwheel if you have some kind of error. It will actually nicely tell you what's going on and even pop up a compile warning in the browser. All right, there we go. You know, let's just make a really simple change. You see it reflects very quickly right into there, and it tells you that it's successfully compiled here. What I want to do now is build out the basic core logic of what I'm actually doing. When you play through the game Hades, you get what are called boons. They power you up. Anytime you pick up a power up, a boon, you'll have 3 choices presented to you, and you can pick one of the 3. My little idea revolves around picking in your game one of those 3 choices and performing an exercise for that particular choice. I need to provide a list of exercises that you can do, preferably ones that you can do with minimal equipment in, say, an apartment. I need to have some functionality that will randomly select 3 choices, and then a way to display those 3 choices so that you know which one to pick as you're playing the game. Using those bits of information, I can actually kind of prototype out the core logic here. And the nice thing is I don't need to render it with crazy graphics or anything. I can actually test this out basically with text. I'm going to begin with defining a list of exercises. Make that a vector of strings, like let's do pull-ups. I need a mechanism to randomly pull an exercise from that list. Here I have the exercises, random value function, run it a few times. Dips, mountain climbers, flies, curls, wide push-ups. Okay, it seems to be working. How does this actually work? If I do get, it expects something that has indexes. Get C, it turns nil because there's no C value there. If I do B, it'll give 2. If I do get on a vector, 0 is the first item, 2 will be the last item in this list here, and it will nil when you don't have valid indices. The reason I wrap V here in a vec is just in case you pass in a list. If I try to get from a list, it doesn't work. It just doesn't index the values. It just connects the list one after the other. You have to realize the whole list by wrapping it in a vec, and then you can get the components out of it. That's why I have this here. Rand int will give you a random number between 0 and 199 if I write this. If you just do the count of V, let's say it's a list that's 10 items long, random integer will give 0 to 9 as possible values, which happens to correspond perfectly with the available indices of that vector. One thing that I have not bothered to consider is the restriction that you can only present 3 different exercises. It is totally possible to get 2 or 3 of the same exercise because every time you run random value, it runs with the same list and has no memory of previous selections from that list. I'm just going to allow that because I don't have a huge list of exercises anyway. So let's make choices component. So div choices, h2 exercise choices, p ran value of exercises. Since there's 3 choices, you just do it 3 times. Modify the doc, basically append it here, choices here, and save this. It should successfully render that component in here. If I refresh the browser, those are 3 different values. So already it's actually working. I could call it done here, but we can do a little bit more, make this a little more interesting. So in the game, every choice you have has a possibility of being common, rare, epic, or heroic. From common up to heroic, your power up increases. So epic is better than rare. The idea here is to tie the number of repetitions that you have to do to the rarity value of the choice presented. I'm actually going to change my data structure a little bit to incorporate that idea. New data structure. I want it to look like a map that has the exercise's name as a string and the reps represented as not reps but something called ranges. I want to have random rep numbers within specified ranges. The range of common reps is from, let's say, 5 to 10. Rare reps can be from 10 to 15. Epic range could be from 15 to 20. Heroic, I will just specify as the maximum. I want to now build a function that can handle converting the ranges here into a specific value that you can display as part of one of the choices. So in order to do that, I have to split the ranges up and pull a random number from within those ranges. So I'm going to end up with 4 numbers, and they'll be randomized every time you pull those numbers. So I'm going to define a function called roll ranges, pass into it an exercise, which will be represented as this map. Destructure this right away by pulling the keys, name and ranges. Now these symbols, name and ranges, are available inside this function to use directly. So to roll ranges, what I need to do is split up the vector of ranges into their appropriate counterparts, letting common, rare, and epic be the result of map v, apply range to the partition to1 of ranges. Def R, this is an example. You can run this function partition on any list, and it will split the list up into segments of whatever size you specify. If I partition this list into 2, it takes 5 and 10, puts it there, and then it takes 15 and 20 and puts that in a list. Partition can take another argument, the step. If I step it by 1, the first one is 5, 10, then it steps forward 1 element, and the next partition is 10, 15, and 15, 20. I can use that to produce exactly the range. All I'm doing here is applying range as a function to those values. Let's take range 10, it gives me 0 to 9. Take range 5 to 10, it gives me 5, 6, 7, 8, and 9. What this is doing is giving me all of the numbers in the range specified here by C, by R, and by E. Using that, construct a new map. The name is going to stay the same. Common, pull a random value from C, run random value over this range. I end up with a number selected from that range. Repeat that for rare, epic, heroic. By definition, is just going to be the last of ranges. That should do the trick. If I build an example exercise, build the roll ranges, and try to run that, it should work for me. I spelt it wrong. So example exercise is this map. Roll ranges with example exercise. It converts the map into a new structure. The ranges are converted into those values there. If I run it again, it is not the same, and that is exactly the intent here. This is not a pure function. When you run it on the same input, it doesn't always produce the same output. This is not a big deal because it's part of the core mechanic that I'm building here. That's exactly the behavior I want. So exercises is now modified. Choices will not render correctly, so I have to change it. I want to make a function that will render this map here. Define a function called Boon. It's going to take in exercise, roll the ranges. I'm going to take all of those keys from result of roll ranges exercise. So I run the function roll ranges on the exercise to convert the ranges of that exercise into randomly selected rep numbers. Anytime I run this function, those will be different or have the potential to be different. I have all the data I need to actually make a renderable element. Probably want to call this Boon Render. H3 will be the name. Strong, common. Okay, that's the Boon Render. And now choices will have a slightly different approach to it. I'll leave exercise choices label up there. Boon Render, random value, exercises. That 3 times. Look at that. Space these out for readability. There we go. When you rerun it, you get different values just fine. Okay, so that is essentially the core mechanic right there. You could actually use this as is to do a legitimate workout. I have a working system. Now is the part where you can kind of gussy it up and make it look all fancy, which I actually have done already. This is my finished product. I'm going to showcase just a few interesting pieces here and there. The first thing that is really important to add is a button that lets you re-roll your choices without needing to refresh the page all the time. So I'm going to show how I can build out a little button that'll actually re-roll things. And in order to do that, I need to employ the idea of state. State is part of your program that can change as you're using it. All I'm going to use state for is storing the 3 rolled exercises, and when you press a button, it just re-rolls those 3, and you get new choices. You press the button, it re-rolls, button, re-roll. Very simple. I want to use a structure enclosure called an atom. Let's define an example atom. An atom is an object that stores state for you. Let's imagine I want to add 1 to that value. You might think I could do this. That's going to fail. And the reason is because it's wrapped in an atom, you cannot access the value without doing what's called a dereference. At example atom, that will dereference it and pull the value and let you run computations with that value. So it produces 2. If I look at exa, it is still 1 because I haven't modified it at all. I can reset it, exa, and let's say set it to 0. If I look at exa now, it's 0. But more commonly, you want to do what's called a swap. You give it a function, and that function will take the value of the atom, perform something, and then put the new value that it calculated back into that atom. Let me just show a little swap, for example. Swap exa, give it the inc function. If I look at exa, the value is 1. If I run this again, that value keeps increasing. I'm going to show you an example of using some state in an actual app here. So I'm going to define something called clicks. It's going to be an atom with the number 0 in it. To define a counting component, it's a function that takes no arguments. Dref clicks so that it displays that value. Add a little input type button. On click is an event that happens, and then it performs some function that you pass to it. And I'm going to use that swap thing I was just talking about to alter the atom clicks by increasing it. Here it is. If I click it, we see that nothing actually happens. Okay, well that's not exactly helpful. What is going on here? Let's look at clicks. Look at that. It is changing. It is reacting to what I do here, but nothing is changing on the display. And this is the power of the ideas behind React and reagent. This is called a reactive atom. I should see the count changing right there. So what is the difference? A regular closure atom will change when you run a function on it. A reactive atom will change when you run a function on it and then tell every component that dereferences it that it has been updated and re-render that component. And that is the power of reactive atoms, and a reactive atom is what I'm going to use to build my state. Define state to be reagent atom, just going to be a vector, and it's going to contain 3 randomly selected exercises. So random value exercises. This will randomly fill the state with 3 exercises every time. The bit of control that I want to add, a roll button. So I'm going to define a function called roll. It's going to take no arguments, and it is not going to swap. It's just going to reset the state every time. I don't need to actually run a function on the state. The state does not depend on itself previously, so there's no reason for me to take the state in and transform it. I can just replace it. Build a little component that houses the button in its own little div. Button on click, roll. There we go, that works. So roll doesn't do anything when I click it. Well, actually, it does do something. It is altering my state, but I'm not using this state to display anything. So the next change I need to make is to wire up my choices option to use the state as the input. Instead of being just a straight component, it's now going to be a function that takes A, B, and C inputs, map Boon Render over A, B, C, run choices, and I need to deref at state. Oh, of course I need to apply choices to the list of state. There we go. Press roll. I see the state changing. So now that I have the core mechanic completely working, I want to take a minute to show a little bit of my SVG library. So let's define example SVG, create a 300 by 300 SVG item. What this is here is the width and the height, and this is the scale value. Let's draw a rectangle. The rectangle's width is 200 pixels and the height is 100 pixels. Plunk it in at the top. By default, my library will center things on the origin. So if I want to actually display the whole, ooh, what a travesty. There we go. If I want to actually display the whole rectangle properly, I'm going to run it through a few transformations. Translate, say I want to move it 100, and in the Y direction I want to move it 50. Save this, and you'll see this move. Move it to the center of the 300 by 300, save that, and you see a change right away. I want to make it look a little nicer. Fill none, add a stroke color of hot pink, because I like hot pink, it's cool. I can change the stroke width, let's say 7 pixels to make it really obvious. There we go. Hot reloading makes this really quick to kind of iterate through different changes of the shape. I can even rotate, and rotate works locally first. I can translate and rotate it in any order and it will not affect the final shape's position. There's even ellipses, circles, polygons, polylines. I use the SVG library to make the frame for the Boon selections in my final result. I think it looks really cool. So I'm going to just run through a really simple half version of that. Define frame component, corner, side length, outer. Create polygon with these 6 points. Make this component the result of SVG polygon path of outer. Slap a style on there. If I save this, I should see the frame component there. This is perfect. If I set C to 0, it gets rid of the corner. If I make it 20, that corner gets much bigger. SL is side length. If I make it 100, the side length shrinks. This is not a frame, it's just a solid block shape. I want to actually cut out the center piece. I'm going to make something called the bounds. Drop 3 of outer. That will get rid of these 3 points that make up that notched corner. To replace it, conj 0, 0 onto that. How do I actually cut something out? SVG merge paths. Pass into it 2 paths. Outer, polygon path, not of bounding box, offset the edge of the bounding box. Use of undeclared variable offset. Yes, of course. Offset is not built into my library. I'm going to copy and paste a bit of code here, and I'm not going to go over it in detail. Save that. There we go. Now let's go fix up this look. Translate it 0, 0. There we go. So when you merge a path that's smaller into a path that's larger, it ends up being a hole. It cuts it. Rotate it 45 and translate it a little bit. Using all of these little things, I can kind of tweak the appearance of things further. This is exactly what I did to produce the final result later. It just has more layers, more color changes, that kind of thing. So this is just a frame. There's more I can put here. Let's do myself a little copy paste favor here. There we go. Put in a rectangle style. Wrong number of arguments passed to rectangle. Yes. It's not a list, it's just 2 values directly. There we go. Now I just need to translate this into the right position. I've got the frame and I've got the background color. And the final thing, and this is I think the coolest thing, this image function, which takes a URL to image and the dimensions, and it works just like any other SVG element. There is my icon. I'm going to show on screen here just a time lapse of me doing 12 of these 14 icons. I think it looks really cool. It was a lot of fun to draw these. That is the basic idea of how I built this Hercules app. Give it a second to recompile. I have produced what, in my opinion, is a great fun app here. You can see all of the exercises displayed here. There's a little blurb I wrote about what this actually is and how you can use it, and you get the nice roll button. You even get a nice sort of spoof on the Hades in-game logo. It actually works. This makes exercise routines that are fun to do, lets you play a fun game, and it actually gets your heart rate going. This project is actually available on GitHub. The link is in the description. You can check it out if you want. I want to keep making these videos, and if you enjoy what I've done here, please consider liking, commenting, subscribing. All that stuff is helpful. Thanks for watching, and have fun with your own projects. I hope this has inspired you a little bit. I hope you can stay fit, stay healthy, and have fun. That's all I got. See you later.